Welcome to The Explainer. Today, we're breaking down a huge dilemma for anyone building a desktop AI rig. It's the classic showdown, the memory-rich veteran versus the super-efficient newcomer.
So, you're ready to dive into AI, right? You want to do some image generation, maybe run some local language models, but you need the right tool for the job. Well, today we're putting two absolute titans of consumer AI head-to-head, the RTX 3090 and the RTX 4080. We're going to help you figure out which one really deserves a spot in your machine.
All right, in one corner, we've got the established champ, the RTX 3090, famous for just an insane amount of VRAM. And in the other corner, we have the challenger, the RTX 4080, built on a much newer, way more efficient architecture. This is the classic battle, you know? Raw power versus modern smarts.
Okay, so to really get what separates these cards, we have to look past the spec sheet. We need to dive deep into their core architectures. And trust me, this isn't just some minor yearly update. We're talking about a fundamental shift in how these things are designed.
So, the RTX 3090. It's built on the Ampere architecture, using a Samsung 8nm process. Now, the RTX 4080, that's powered by the newer Ada Lovelace architecture, and it makes this massive leap to a 4nm process from TSMC. And that smaller process, that is a huge deal. It means way more efficiency, and it lets them pack in the newer 4th-generation tensor cores.
And that generational leap? Well, that's what creates the central conflict here, the big trade-off for anyone building an AI rig. It forces you to make a really tough decision between two incredibly important things, just raw memory size on one hand and pure raw efficiency on the other.
Let's talk about the RTX 3090's undisputed crown jewel, that massive 24 gigabytes of VRAM. Look, when it comes to AI, VRAM is king. End of story. More of it means you can load bigger models, bigger datasets right onto the GPU, and you don't have to deal with the slow crawl of using your system RAM.
So, you might be asking, when does this actually matter? Well, it's absolutely crucial when you're training your own models and need to fit a ton of data at once, or for using bigger batch sizes to speed things up. And for those really complex Stable Diffusion workflows, yeah, those can eat up memory like crazy. If you're someone who is constantly hitting that VRAM ceiling, the 3090 is basically your get-out-of-jail-free card.
But here's the 4080's counterpunch. It has a total graphics power, or TGP, of 320 watts. That's a full 30 watts less than the 3090. That right there is the power of that 4nm process. It's just doing more with less. And that efficiency, it has real-world benefits that you'll actually feel. We're talking lower electricity bills, which really add up if you're running these things for hours or even days on end. It also means the card runs cooler and probably quieter, which can lead to way more stable and consistent performance during those marathon AI sessions.
Okay, let's get into the raw specs and see how this all stacks up on paper. This is where we get into the real nitty-gritty, you know, the cores, the clocks, the bandwidth. You know, NVIDIA themselves made a huge deal about this with the 40 series launch. They basically said, hey, this new architecture, especially these 4th-gen tensor cores, gives you a massive performance boost for the exact kind of math that AI thrives on.
This table really lays out the trade-offs perfectly. You can see the 3090 leads in raw CUDA cores, and it has more of those 3rd-gen tensor cores, and of course, all that VRAM we talked about. But it's the 4080's newer gen cores and that incredible efficiency that make this such a nail-biter of a race. Now here's a huge point for the 3090. Because it has a wider memory interface, think of it like a bigger highway for data. It boasts a staggering 936 gigabytes per second of bandwidth. The 4080 is still super fast, don't get me wrong, but it just can't match that raw data-moving power, which is so critical when you're shuffling massive datasets around.
So, what are these tensor cores we keep talking about? Well, they're basically the engine room for AI on these GPUs. They're specialized processors that just crunch the specific math AI needs. Now, here's the key thing. While the 3090 has more of them, the 4080's 4th-gen cores are just plain smarter. They support newer tricks and data formats like FP8, which lets them process certain AI jobs way more efficiently. It's a real case of quality over quantity.
All right. So we've looked at the architecture, the memory, the efficiency, the raw specs. With all this info floating around, how in the world do you actually pick the winner for your setup?
Honestly, it really boils down to this. If your work is constantly, and I mean constantly, getting stopped by VRAM limits, then the RTX 3090 is your champion. It's the clear choice. But
For pretty much everything else, especially if you're doing a lot of inference or you just really value efficiency, the modern architecture of the RTX 4080 is going to give it the edge.
So here's a little 3-step guide to help you pick your champ. First, just analyze your workload. Are you always seeing those dreaded out-of-memory errors? Be honest. Second, what do you prioritize? Is that raw VRAM more critical to you than lower power bills and less heat in your room? And third, based on those answers, make your choice. It's that simple. Now look, we've tried to boil down the key points for you here, but this is a really deep topic. A lot of our analysis is based on some fantastic work done over at Best GPUs for AI. If you really want to get into the weeds with more benchmarks and comparisons, you got to check out their full breakdown. We've got the link right there for you, and it's in the description below.
You know, this whole comparison leaves us with a really fascinating question to chew on. As AI models just keep getting bigger and bigger, what's going to be more important for those of us building rigs at home? Is the future all about just cramming in as much memory as physically possible, like the 3090's approach? Or is it about creating smarter, more efficient architectures, like the 4080, that can do more with less? Honestly, the answer to that is going to define the future of desktop AI for all of us.